Hello, good morning. Just give me a minute, we'll start then. Hi, Ritvik Ramcharan. How are you? How was your exam? Good morning, Samir. Okay. Okay, so how was the experience? How was the exam? Just a second. हाँ गिट हाँ मैंने भेज दिया अभी. Yeah. So tell me, how was your experience? How was the exam? JEE Main. Chemistry was easy, right? Okay, overall moderate. So what is the marks you are expecting? Anyone above 200? Anyone above 200 you are expecting? Okay. Okay, tell me one more thing. When is your board exam? Have they declared the date? March 2nd. Okay. And how many of you are, I think some of you are obviously planning to write JEE Main in March also, right? Okay, so you must have seen the paper, right? Yeah, so all of you who are planning to write JMain in March also, right? We have enough time, more than a month we have to prepare. Okay, I know in this time you have board exam also, but you can, you can do that, because if you have seen the paper, all the paper, if you have seen, they did not ask any tough questions, right? The question were not tough. In chemistry, what I can see, that there are some factual questions are there. Okay, like the pH of rainwater, or like the isotopes of hydrogens. There are very factual questions are there, and if you see those questions from inorganic especially, those are mainly from NCRT, right? So that's why I told you already that for inorganic chemistry, NCRT is more than enough. If you have studied line by line NCRT, you can do all those questions, right? So JE main has been changed a lot over the year now, right? Since you can also understand like this, earlier last year what happened, they have to prepare 30 questions in 30 questions in chemistry, 30 in physics, and 30 in maths, right? In 1 year they have to prepare only 30 questions in each subject, right? So they can work on these 30 questions, so obviously you'll get better questions over there. But now what happens, you see, from 8 to I think 13, almost a week you have exam, right? 7 days, 6 or 7 days, correct? And each day you have two shift. Now if I'm talking about chemistry itself, there are 60 question total in 1 day. In 7 day it will be 420. Roughly I'll take 400 questions only, right? 420, so under around 400 questions only. Similarly, you have one more exam in March. There also you'll have 400 questions more. So in one subject, they have to prepare now 800 questions, right? So if you think like this, earlier where they have to prepare only 30 questions, now this 30 becomes 800. So where they'll collect these 800 questions? They cannot give you some new questions into this. Okay, so they have to pick up the questions from here and there, from the books or from any other exams. Okay, so that's why the questions, you may feel that the few questions were repeating. Is it there? Is it like that? Few questions, have you felt that the questions were repeating? You have solved all those questions like from any other book or in problem solving session, you must have seen those questions. Yes. Uh, right, so that's why I, from this 1 month. Yeah, actually, and in chemistry also there were questions like which of these molecules according to MOT are stable or not. So question was He2 plus, then we have He plus, something like that. The question was there, the based on bond order. Okay, so I can see there are many questions were there which you have seen somewhere here and there. Okay, yes, many was similar. Many was similar. So that's what the thing. So the point I'm trying to make is what? Again, they have to prepare this 800 questions. So you are not going to get any new or difficult questions. Okay, you will get easy questions only, and those questions you must have solved already. The only thing is that you have to keep on revising those things again and again. Okay, from this exam, what we can say. Right. So that's what the thing is. Okay. So what I suggest you in this one complete month, that again you have to concentrate on board exam also, but parallelly you have to do inorganic chemistry. Again, NCRT you must solve. Okay. And wherever you get some factual question, especially in inorganic chemistry, factual question, you just write it down in a diary or notes. Okay, so that in 1 month you have a, a good number of factual questions, so that you can revise this question in the last 1 week. Okay, so like this you have to prepare. Numericals, I think, I just wanted to know from your side, as far as numericals were concerned, which has been asked in JEE main exam, do you get any difficulty in solving those numericals? Like I'm talking about chemistry. Do you get any difficulty in solving those numericals? I'm talking about this in a general term. I know all questions obviously you cannot solve. Yes, so the point is numericals were very direct and formula based, if you see. All direct formula, yeah. So that's what. So you don't have to worry with numericals. Okay, if they ask very tough numericals, that would be only probably one or two questions. Don't worry with that. Okay. So what you do in this coming 1 month, just you revise basic formula, right, and theoretical questions also. For theoretical questions, what I'll suggest you that you must go through the previous year NEET exam questions, NEET and AIPM. Sorry, this AIMS question, NEET, AIMS, whatever the medical examination, chemistry, physics portions are there, that you must solve. You'll get a fair bit of idea over there. Okay, because I have seen many questions that have been asked in JEE Main this year. They have already asked in NEET exams, right? So that's what the point I'm trying to make. That in this 1 month, try to focus more on very basic question, formula based question, theoretical questions, and NCRT for inorganic chemistry. How do you solve this theoretical and formula based question? The best way is to solve all NEET exams or AIMS paper. Okay, you will have fair bit of, because in NEET and AIMS exam, if you say they ask the question like this only, formula based question, little bit of trick was there, but not that much stuff. Okay, so that's what I think you should do in this 1 month. Understood this? Okay, stop thinking about what has already done. Okay, now what experience you had from this JEE Main exams? With that experience, what changes you should do in your strategy? Think on that for a day. Okay, take your time and then start working onto that, the new strategy. Okay, so that is very important. Okay, anyways, now we'll start the class here. You see, I like whatever question I have seen, there were no any questions which is based on tautomerism. Did you see any question based on this tautomerism? I haven't seen any question based on tautomerism this 1 week. Okay, so there are high possibilities that next time you'll get question from tautomerism. Okay, and you also work on this. Whatever portion are left now, see, just you talk all of you with each other, right, and try to figure it out that in chemistry or in physics or in maths, what portion they haven't touched, right? Last year also, what happens? Offline exam was there. JEE Mains. Let me tell you this. Offline exam was there. In offline exam, they haven't asked anything about, polymers. Hardly they have asked anything about polymers. Okay, Twitter and all. This thing they haven't asked. So one of the student here in Centum Academy, that time I was newly joined over here. So she asked me, sir, what should be the important topic for online exams? So I have gone through the paper of offline exam, and then I figured out that polymers, they haven't asked any question, much question from polymers. So I suggested her that you should revise polymers once, and in polymers, deuterion concept is important. So you must revise at least that much, okay, and then some formulas of that. And in online exam, they have exactly got one question which is based on deuterion concept. Okay, so that is what I'm trying to, the point I'm trying to make, that you all talk with each other and try to figure it out. Okay, like we are also working on it, and try to figure it out that which portion in math, physics and chemistry they haven't touched in this exam. Okay, those portions you try to cover first. Okay, because there are high possibilities that you will get questions from them. Okay, that you must do. Anyways, so we'll discuss a bit of concept of tautomerism. We have already discussed this thing, but since this is a revision class, problem solving class, we'll solve some problems also, right? But since tautomerism, again it is a factual question, because if they ask you some Questions like what is the percentage enol content and which product is stable and all, where the enol is stable or keto is stable. So for that, that is based on the experimental thing, right? And from few, few logic you can put into that. Okay, so that's why I'm discussing tautomerism first, and then we'll see some questions of any of the 11th grade topic, because I am assuming this, since you have board exams, so you're already in touch with 12th grade topic, right? So I just wanted you to be in touch with 11th topic also. Okay, so that's what we'll solve some questions of 12th grade also. Okay, but today we'll see some 11th grade topic only. So here we are starting with tautomerism today. See, tautomerism is what? Tautomerism is a special type of functional isomerism. I am not going to dictate you anything into this because we have already done this. Okay, so whatever the important points are there, I'll write it down. If you want to write it, you can note it down. Okay, so this is a special type of functional isomerism. Since we have change in functional group, right? Keto converts into enol, right? In this, what happens? The isomers, they exist in dynamic equilibrium. Isomers exist in dynamic equilibrium. So the isomers are in this type. Isomers are interconvertible. Interconvertible. Okay, so they can convert from one form to another form, right? But their structures were different. Okay, these kind of isomers or this phenomenon is tautomerism, right? Now, how many different types of tautomerism are possible here? So I'll give you some examples into that. They may ask you this question also. Okay, so you see, first of all, the very basic and we all know this type of tautomerism, that is ketoenol tautomerism. Ketoenol. So ketoenol is nothing but this CH3 C double bond O CH3, and this converts into CH3. This is ketoenol. One more type we have, that is nitrosooxime. Okay, in this nitrosooxime also, tautomerism is possible. Like you see the example here, single bond N, double bond O. This is nitroso. Oxime will be what? One H will come over here and we'll get double bond here, right? So it will be H2 C double bond and OH. So this is nitrosooxime. Have you heard about imine in amine? This is important. Imine in amine. Imine is nothing but this. We have CH3 NH. This is imine. And enamine is H2C double bond NH2, sorry. Why it is enamine? Because ene stands for this double bond and this is the amine group. That's why it is enamine. Next one is imidol. Amido is this H2N C double bond O, and imidol is OH. Azohydrazone. Azohydrazone. In azo, what we have? We have N double bond N, right? CH3. This converts into H2N single bond N double bond CH2. Double bond CH2. The last one we have here, that is diazonitrosoamine. That will be aryl group N double bond N OH. Conversion of this into aryl NH single bond N double bond OH. In all these type of compounds, tautomerism possible, right? The mechanism of this we have already discussed. I'll just discuss it again quickly. Okay. So here you see all these adjacent carbon sp3 hybridized we have here. So this hydrogen, any hydrogen or alpha hydrogen, right? We can say these hydrogens are alpha hydrogen. So alpha hydrogen are involved in tautomerism. First of all, this thing you have to keep in mind, right? So the sp3 hybridized alpha hydrogen we have here, these hydrogens are acidic. Okay, alpha hydrogen are acidic. Acidic means what? These molecules can lose this hydrogen easily as H plus. Correct. So what happens here? If this hydrogen comes out as H plus, right? Oxygen already has lone pair on it. Similarly, in all these cases, oxygen has lone pair here. Here, nitrogen has lone pair. One lone pair only. Oxygen has lone pair, like this it is. Okay. Here, this nitrogen has lone pair, right? So because of this lone pair of electron, this H plus has tendency, because once this molecule lose this H plus ion, so the ion that is left over here is H2C single bond C double bond O CH3 with negative charge over here, right? Now this H plus from this alpha hydrogen has tendency to come out and then again attach to this molecule, right? So when H plus, suppose when this H plus wants to attach with this ion here, so there are again two possibilities. What is that? That this H plus may attract it towards the lone pair of this oxygen, or it may attach to its initial position, which is nothing but the carbon atom. Okay. And this process is spontaneous. We are not doing anything into it. All these things happens on its own, depending on the stability of these two products. Okay, which one is, suppose this one is more stable, then H plus has more tendency to attach on this oxygen atom, not on this carbon atom, right? This is acetone. The meaning of this is what? Suppose in a bottle, if you take acetone, right? 100% acetone, suppose if you have in this bottle, right? Initially, the composition of this is 100%. So after some time, if you try to find out the composition of acetone, it would be less than 100%, right? On its own, we are not doing anything into it. Because what happens, some of this part of acetone has been converted into enol by this reaction, okay? So when this H plus attach over here, you will get this product. When H plus attach over here, you'll get the initial product, correct? So in all these molecules, the tautomerism is possible. Mechanism, if you see, I'll just because this mechanism is not required, but one thing you just keep in mind, because tautomerism is possible, tautomerism is possible in both acidic and basic medium. Acidic and basic medium. Right? I'm not discussing the mechanism in all this. That is not required. Okay, so I'm leaving that part. Okay. If you want to know the mechanism, to discuss the mechanism, I'll discuss that also. Let me know if you want me to discuss the mechanism quickly. Okay. So you see the base catalyzed mechanism. First of all, we'll see in presence of base how this reaction proceeds. Suppose the molecule is this RCH2. Okay. So the base that you have here, which is OH minus, this OH minus will take this alpha hydrogen, right? This OH minus, because of lone pair here, this will take this alpha hydrogen, right? And this is a keto form. So when it takes this alpha hydrogen, so what we get here, and this bond, it takes H plus and this sigma bond shift over here. And in this case, this pi electron will shift onto the oxygen atom, correct? So the product we get here is this RCH double bond C single bond O minus R, right? Single bond O minus and R. Next, what happens? This ion, we call it as enolate ion. Okay, this is enolate ion, which further converts into, because we have this H and OH minus forms what? H2O, right? So this H2O only has tendency to lose H plus ion, and that H plus will attach on this oxygen or this carbon depending on the stability, correct? So suppose this negative charge we have here, we have three lone pair here, this will attack onto this hydrogen, and this bond comes over here. So we'll get what? RCH, RCH double bond COH R plus OH minus. The base will be as it is when the reaction ends. Right? This is the enol form. So this is how the reaction proceeds, the mechanism we have. One thing you must keep in mind in this kind of reaction, that the carbon across C double bond O, I'll write it on here, this you must copy. The carbon across carbonyl group which contains more number of hydrogen which contains more number of hydrogen will take part in the reaction. Will take part in the reaction. Meaning is what? Suppose if I write down this molecule RCH2, C double bond O, CH3. Then the product in this is what? In base catalyzed reaction, we have RCH2, single bond COH, double bond CH2. Carbon which contains more number of hydrogen atom, from there only the hydrogen take part in the reaction. Understood this? Yeah, I'm doing that. This is the base catalyzed mechanism. Okay. So did you understand this? Can I move on? Okay. So this is very important point we have in base catalyzed mechanism. Must you keep this in mind, because in acid it is reverse. Okay. That's why I have given you this in note. Okay. So in base catalyzed, the hydrogen comes out from the carbon which has more number of hydrogen, alpha carbon, right? But in acid it is reverse. See this. Acid catalyzed mechanism, you see. Suppose the reaction is this RCH H C double bond O C and R will take, generally only will take, but I'll take CS3. That would be, I think, better option way, I think. Let me write this CS3 only over here. Since it is an acid catalyzed reaction, water we also use. So acid will give H plus, correct? So whenever if you have acid catalyzed reaction and carbonyl carbon is there, so the lone pair of that oxygen takes part in the reaction first. So this will attack onto this H plus and this hydrogen will attach over here. Okay. So what we get here, you see, RCH COH double bond CH3. This will have the positive charge, right? Now, in this, what happens? The H2O molecule, because we are taking here H3O plus acid with this water. So the H2O molecule that you have, oxygen has lone pair. This lone pair has tendency to attack in any one of this carbon atom, right? And in this case, what happens, what you have to keep in mind, that this water will take hydrogen, which from the carbon, from the adjacent carbon, which has lesser number of hydrogen, right? So this oxygen or lone pair will attack onto this hydrogen because it has two hydrogen, here it is three, right? Then this bond pair goes over here and this pi electron will shift onto this oxygen, right? So the product we get here is RCH double bond COH and CH3. This is the enol form. This is keto, right? So in this mechanism, acid catalyzed, what you have to keep in mind that the hydrogen comes out from the adjacent carbon which has lesser number of hydrogen. This is the difference we have in acid and base catalyzed mechanism. Right? Few example you see on this questions. Suppose the molecule is this. This is in presence of acid and this reaction in presence of base. First one. Second one, acid and this is base. Tell me the product. Means suppose it is 1, 2, I'll not write on this, otherwise you'll get confused. Suppose this is first and second carbon is this, and this is first and second carbon is this. In the first question, hydrogen comes out from which carbon for acidic reaction, this product? This will tell you, for this reaction, acidic medium, hydrogen comes out from which carbon? From the second carbon. Right? And basic medium, hydrogen comes out from the first carbon. Similarly, you can write down the product here also. Fine. Okay. Can we move on now? Okay. Next, you see the very important point we have here, that is stability of enol form. And in this section, whatever I am going to discuss, that you write down properly. Okay, because these are based on some some logic, but again, percentage in all content and all, you have to memorize, because I have seen few questions in in other different books, that sometimes they have asked the percentage in all content also. Okay, so whatever example I'm going to discuss here, these examples are very important. Okay, you will get this question direct. Okay, or if you're not getting the same question, you will definitely have a fair bit of idea from if you have this data in your mind. Okay, that's why these are important. So stability of enol form, this is very very important. Okay, first case in this, in case of monocarbonyl carbonyl compound, means where we have only one C double bond O group. For example, you see CS3 C double bond O R, right? The product of this will be what? This hydrogen comes over here. Directly what we can write, this hydrogen will jump over here and we have a double bond over here. So the product will be CH2 double bond C OH and R. Now if you see the percentage enol content over here, this is very less, 10 to the power minus 4% of enol. Rest is keto form only. Means here the keto form is more stable. Keto form is more stable than the enol form, right? So the reason behind this, if you see, here you have carbon-carbon double bond, right? Uh, the reason of this, you see, the first thing, that in this keto form we have C double bond O, and the enol form we have C double bond C. Okay, so the bond energy of C double bond O is, suppose I'll write down this bond energy 1 and this bond energy 2. So the bond energy of C double bond O is quite higher than the bond energy of C double bond C. Okay, so that's why this bond is difficult to break and this bond is comparatively easy to break, right? Hence, this one is more stable than this. So keto form is generally more stable than the enol form, right? But we should have some condition over there also that we'll discuss one by one. Another, another reason here it is what, that in this carbonyl group C double bond O, this is resonance stabilized also, means there are possibility of resonance over here. So C plus and O minus, right? This particular type of separation of charge is comparatively more stable than carbon-carbon. If you try to separate the charge over here, we have C plus and C minus. So if we have positive and negative charge on the adjacent carbon atom, then this is highly unstable compound, right? C plus and C minus is highly unstable compound we have. Okay, so that's why this keto form is more stable than the enol form. Understood this? Okay, these are the two conditions you have to keep in mind. Just a second. Coming in a minute. Just. Okay, just a second. Right, so keto form is generally more stable. Yeah, it's in basic medium. Yes, Shweta, it is in basic medium. Generally, we do this tautomerism in basic medium only. Okay, if nothing is mentioned, it means it is in basic medium. And if they ask you, see, actually, you try to understand one thing. Right, Vishist. Actually, you see, they don't ask this question, like, why I am not, why I said that the mechanism is not important. The reason I'll tell you now. They never ask this question that what is the product you get in this tautomerism of this CH2 3 C double bond O CH2 CH3. They never ask the product here, right? What they'll give you, sometimes they'll give you A, B, C, D, four different, product here, and they'll ask you the percentage in all content of all these product, and they'll give you 10 to the power minus 4, right? 10 to the power 2, like this, they'll give you the option. So they talk about the stability of the tautomeric product. Understood my point? So they usually ask about, because it is no point, like if they ask you this question whether it is basic medium or acidic medium, if nothing is mentioned, then you can take this as basic medium. But if they have mentioned already the medium, you know what should be the product, correct? So that you can do easily. But I am trying to focus on that if they ask you the stability of tautomeric product, then what all logic you can put in. Understood? So that's the point. But whatever the medium it is, you can apply those logic for all these products. Only the product will be different, but stability, if you talk about, that logic is applicable for all the product, whether the medium is acidic or basic. Right? Now, similarly, you see this question. See, I'm giving you all these questions in a series, right? So that you can memorize this. All these examples you must memorize. In this, when I write down the tautomeric product, it would be this. We have a double bond here and OH, correct? right? Now, if you see the percentage enol content of this, that will be 1.2% here. Okay. So when you compare the stability of these two, obviously this one is more stable, right? Because 1.2 is this, means 98.8 is this molecule, right? So, but when you compare these molecules, like the first example that I have taken, which is nothing but this one, which is the chain enol form. The first example which I have written, that is CH2, double bond C, OH, and R. This molecule was the product in the first example. So if you compare the stability of these two, then this cyclic one is more stable than the chain one here. The reason of this is what? So first of all, you write down here, this compound is more stable as compared to more stable as compared to aliphatic enol form, right? Means if you're comparing these two. So whatever comparison you are doing, just to keep this in mind, because I have seen these questions, exactly same question they have asked directly many times in the exam. Okay, test paper exam or in the books. Okay, that's why I'm picking these examples. Okay. So if you compare the stability of these two, this one is more stable. The reason behind this is what? Because of the, this is because of free rotation, free rotation of OH bond. Okay. So what happens here? This OH bond that you have, this entropy, we call it as free rotation of OH bond, that will increase the entropy of the system, entropy of the molecule. This entropy, we call it as Zero's entropy, GEROS. The name is not important, right? But the point is what? This molecule, if you see, we have a double bond here and then OH. So this bond has a free rotation, right? We'll have a free rotation over here. Because of this only, its entropy increases. That rotation is here also. But since this is a linear compound we have, so because of these molecules present here, it will be a bit hindered, or the increase in entropy here, it is lesser than the increase in entropy here. Right, that's why this aromatic enol form is more, sorry, the cyclic enol form is more stable than the aliphatic one. Okay, so just this logic is, it is not that important. Okay, it is not actually, this entropy is not in our syllabus also. Okay, so you can, let it be, it's not required. But the thing you have to keep in mind, if you have cyclic enol form, then it is obviously more stable than the aliphatic enol form. Now, how do you compare the stability of the other products you see? In this only, if I give you this molecule, you see, in this, the tautomeric product will be this. This double bond will be as it is. Here we have a double bond and then we have OH. So now we compare the stability of these two. Obviously, this one is more stable. It is almost, more than 90% stability of this we have composition. Among it is not lesser in concentration. You have mixed two things. The concentration of this with respect to this, I'm telling you. So it is 98.8%. Okay, so if you compare the stability of these two, this one is obviously more stable. Content is also more, right? What is the composition of this one? 10 to the power minus 4%. So this is obviously more than this, right? So I'm comparing the stability of the product of two different tautomeric reaction. Okay, that's what I told you. They'll give you four different product here, reactant here, and what is the enol content? They'll give you the option over here. So this is what we have to compare the product. That's why I'm comparing the product here. The first product is this and minus 4. It is 1.2%. When you compare this, so this one is even more stable than these two, right? Because this is aromatic, right? This benzene ring is aromatic, so its stability is more than 90%. Okay, so that is also one thing we have. So this is possible when we have monocarbonyl group present. Fine. Now we'll see the second case where we have dicarbonyl group, means two carbonyl groups are present. Right? So case 2 you write down. In case of dicarbonyl compound, in this also we'll consider open chain first and then we'll see the closed chain. Okay, cyclic compounds. You see if the product, if the reaction, if the molecule is this C double bond O and C double bond O, carbon. Right? So when you have carbonyl group present at adjacent carbon atom, so we have lone pair here and here also we have lone pair, right? So we have what lone pair repulsion. To reduce this lone pair repulsion, what happens? One of this side, one of this group or this group will rotate, right, across this carbon-carbon single bond. So you see here, to reduce the lone pair repulsion, the group, the half of this molecule flips in a different direction so that the repulsion reduces. So what happens here? To reduce lone pair repulsion, the molecule rotates. Half of the molecule actually rotates. So when this rotation takes place, then the molecule is this C double bond O and C. This is the molecule we have. Now in this, when you write down the enol form of this, that would be possibly this. Only one C double bond O group will take part. Both will not take part in the reaction. That is not possible, right? So we'll have this product, correct? This is one case we have discussed. Now another case is what? When we have cyclic compounds. Why I'm discussing both together, that you see, then we'll see the percentage content of this. If you have cyclic compound like this, suppose, OH double bond O. This is the product we get. Now here you see what happens. This molecule here, the rotation is hindered, right? Here the rotation of this, like this, the rotation here is not possible in case of cyclic compounds because the rotation is hindered because of this ring, correct? So the C double bond O cannot go to the opposite side here. When this rotation is hindered, so this molecule will get stability through this hydrogen bonding. Okay, so that's why this compound is highly stable than this, and the content of this is almost around 100%. This will be 0%. But here, since there is no bonding, so stability of this is quite lesser than this. So it will be 0%. This will be 100%. Remember again one thing in mind. We'll discuss that, Shruti. Just give me a few more minutes, okay? When methyl group is in between, then we'll discuss. Okay, we are coming to that only. Few more minutes, give me. Right. So you don't have to again compare these two. What you have to keep in mind that in cyclic ketone, right, the enol form is more stable than it is in open chain compound. Right. So this comparison you must have. You must keep in mind. Right. So because of hydrogen bonding. So one factor is what? See, the first factor is what? The bond energy of C double bond O and C double bond C we have discussed. Right? We have discussed about entropy also, which is not in our syllabus, but we have discussed this. We have discussed now hydrogen bonding, the third factor. All these factor affects the stability of the enolic form, right? So that's why these three factors we have discussed so far. Okay. In the ring, what we can write here, we have restricted rotation, right? We have restricted rotation here. And that is why the molecule or the product is hydrogen stabilized through hydrogen bonding. Okay. Now the second case in this we have in this the case B, when we have 1,3 diketone. For example, you see the molecule is CH3, C double bond O, CH2, C double bond O, CH3. This is what you were talking about, Shruti, right? Okay, correct. Now you see this, see again, because this carbonyl group, this hydrogen is also acidic, this hydrogen is also acidic, and this hydrogen is also acidic because of all this carbonyl group. But out of these three, 1, 2, and 3, which one is the most acidic hydrogen? Can you tell me? The previous one. See, actually what happens, first of all, we are comparing this and this. Okay, so since hydrogen bonding, through hydrogen bonding, the stability will be there. So all these molecules will convert into enol form like this. Okay, and here what happens, see again, it is why it is 0% or 100%. This is the factual thing we have. It's a fact. Okay, like I said, it is a spontaneous process. You cannot, we are not doing anything into it. You take this molecule in a sample, you take this molecule in a vessel, okay, and after some time you try to measure the content of this in the same vessel for this molecule. If it is changes, right, then some of this has been converted into enol form. But in case of this 1,2 diketone that we have, and if the molecule is a chain molecule, we have aliphatic compound, then it won't convert into the enolic form, right? Because there is no, uh, since the flip is there because of this repulsion, and through this flipping, the product that we get, the enol form, that is not at all stable because of what? See, here we have pi sigma pi conjugation is there right here, and here also we have conjugation like this lone pair pi and sigma, right? So this lone pair is coming into bond pair, and if you see here the stability here, number of covalent bond is more over here, right? One thing is what, if you consider, you see this, see, first of all, why it is 0 and 100%, that is of experimental fact, okay? That's what I have given you this. But if you try to understand this, two things you can see over here. One thing is what, this is resonance stabilized, correct? First of all, we have two C double bond O group here. Here we have only one. And we know C double bond O, the bond energy is more than to that of C double bond C. So we have two C double bond O, so this is more stable. First thing is that. Second thing is what? This is resonance stabilized, right? When I say resonance, you can ask me, sir, here also we have resonance. Here also we have resonance. Correct? So this resonance, then this lone pair is involved in resonance. This is one type and this is another type. So this gives you the cross resonance. So cross resonance is highly less stable than the normal one. Right? So with all these facts you see, through resonance also this one is more stable. Through bond energy also this one is more stable. So since this compound is more stable here, so this compound has very less tendency to convert into its enol form. That's why it is 0%. Correct? Now, the next one that we were discussing is 1,3-diketone, right? So you see here, like I said, which of these hydrogen is most acidic? Obviously this, which is the middle one, because this hydrogen is affected by both carbonyl group equally, right? But the effect of both carbonyl group on this and this hydrogen is not that much, okay? So this is the most acidic hydrogen we have. And this is the methylene group, and we call it as active methylene group. Active methylene group. Okay, active methylene group. So whenever the methylene group is present between two carbonyl group, it is always active methylene group, and hydrogen always comes out from this carbon, not from these two, to get the stable one. Okay, so the product that we get here is this. One of this hydrogen comes out from here, and that will attach any one of this oxygen atom. So the product will be this CH2, C single bond OH, double bond CH, single bond C, double bond O, CH3. Okay, so the percentage content of this is 76% here. Rest is this only. So this one is more stable here. The enol form here, it is more stable. So you cannot say that always keto form is more stable. It depends on what compounds, what group you have. Correct? Now, why it is more stable? So there are two, three, logic you can understand. The first one here it is intramolecular hydrogen bonding. Okay. So intramolecular hydrogen bonding, how it takes place, you see. This molecule, I am going to draw it over here. CH double bond C. Here we have CH3 and here we have CH3. So this is first carbon, second carbon is this. Sorry, we have CH3 here. Then we have CH3 here, this CH3 here, and we have this bond like this. So we have a intramolecular hydrogen bonding present here, like this. And because of this only, it is more stable. Because of intramolecular hydrogen bonding. Okay. Yes, yes, yes. Always hydrogen comes out from the active methylene group. In this case, 1,3-diketone. Always. So, like I said, in this, there is no, thumb. We don't have any thumb rule into this. Okay, it depends on what molecule you have. Because of the, minus R group of this, minus I group of this. These two has electron withdrawing group, no. So the effect of, for this carbon atom to lose H plus is dependent on the nature of I group here. So both I group is it is strongly affects the acidity of this carbon atom, this hydrogen atom, right? So because of both this carbonyl group, this hydrogen becomes most acidic. So obviously this will come out as H plus always, right? So first reason is what? Intramolecular hydrogen bonding possible like this. Okay. There is one more reason we have, and that is the large size conjugation, or large conjugation also you can say. Large conjugation. Which means, I'll show it here only. This lone pair is in conjugation with this pi bond. Right? And this will come over here. This will come over here, and then this will come over here. So this is a large size conjugation we have. This kind of conjugation is not here. Can you see any conjugation here? Because of this resonance also, this is more stable. Right? Third part is what? Due to hyperconjugation. Stability due to hyperconjugation, which depends on the number of alpha hydrogen. So there are 3 alpha hydrogen present. So you can draw 3 hyperconjugative structure, right? So that's why this is more stable. So these are the 3 things we have: intramolecular hydrogen bonding, conjugation, which is nothing but resonance, and hyperconjugation. All these affects the stability of the enol group, right? So this is very, very important. This active methylene group that we have. In this, there are many different, possibility. Like we can have different group present like this. You see the second example I'll take into this one. Instead of methyl, suppose we have phenyl group, pH, C double bond O, CH2, C double bond O, pH. Its enolic form is what? pH, C single bond O, H, double bond CH, C double bond O, pH. Right? Now in this, what we can say, because of this phenyl group, we have what? We have extended conjugation. With this also we have conjugation with this. Because of the extended conjugation here, this compound is highly stable than the previous one, the previous product, and its stability is almost around 96%. Its composition is almost around 96%. Highly stable, this one. So it depends on what groups are attached with it. Suppose if I replace this by hydrogen, then the product will be and H. So you compare the stability of this and the previous one where we have CS3 here, right? Okay. So what happens here? Because of this hydrogen, which is smaller group here in comparison to CS3, the hindrance is less over here. Hindrance here, it is less than the first example that I have taken when we have CS3 present here. Correct? So we have less hindrance, but there is no extended conjugation into this one. Okay? So obviously this one is more stable than the first one, but less stable than this second one. So first one is 76%, this one is 96%. So this one will be roughly around 84% conjugation this year. Okay. One more example you see here in the same time. CH3, C double bond O, CH, C double bond O, CH3. Here also we have CH3. So what is the difference between first and fourth? The first one we have CS2 here, and here we have CS3. Correct? So when you draw the enol form of this, the product will be CS3COH, double bond CCH3, C double bond O, CH3. Right? So when you draw the structure of this, here also the intramolecular hydrogen bonding is there. So this carbon is here. This carbon is here. C double bond C OH, single bond C double bond O. Here we have CH3. Here we have CS3, and here we have CS3. So here also we have intramolecular hydrogen bonding, right? But at the same time, what happens? We have repulsion also in these three methyl group. I am comparing the first and this one, the first product and this product. Right? I'm continuously telling you, we are comparing the stability of product. Correct? So this one is highly stable because here we have extended conjugation. In the first one, we don't have extended conjugation. The first one is 84, this one is 96. Here we have less hindrance, then we have CS3 present over there. So its composition should be more than the first one. So first one was 76, so this one is 84. Right? Here, if I replace one of this hydrogen atom by CS3, we'll get this product. But since this methyl group is what? We have steric hindrance over here, then this composition is lesser than, or it is very less than, very small, very like, um, it is, the composition of this is very small, right? And that would be somewhere around 7%. Okay, so very less than the first one. Okay, because of this hindrance of this methyl group, right? However, hydrogen bonding is there, right? So again, you can ask me, sir, hydrogen bonding is there, then why not this should be more than this? You can ask me. But there are two factors. Hydrogen bonding is providing stability to this, but steric hindrance is providing instability to this, right? unstability to this. Because of this hindrance, this molecule is becoming unstable. So which two factor is dominating? Depending on that, the composition of the product will be. Right. So here this methyl group is, the hindrance among this methyl group is dominating over the hydrogen bonding factor. So that's why it is only 7%. Right. Again, if you replace this methyl group by any other larger group, then the composition of enol will be 0%. For example, I'll give you one more here. If this methyl group is replaced by any larger group, then the composition will be of enol will be 0%. So it is probably the fifth one. Suppose we have C double bond C. And here we have isobutyl group. Isobutyl, isobutyl. So this group is obviously it is quite large, right? So for this case, the percentage enol content will be 0% enol because of the hindrance in these three. Right? So hindrance is also one of the factor we have. Steric hindrance. One more example you see. We have CH3, C double bond O, CH2, C double bond O, O ethyl. Okay. This is what? This has minus M effect. Weak, but yes, it has minus M effect. Just a second. Oh yeah. Just make a small change here. This is not 7%, this is 44% actually. Make this change. This is 44%. Lesser than the first one. So it is 44, not 7%. By mistake, I have written that. Okay. Make this correction. Not 7%, is 44%. 7% is this one, I guess. Right. So because of this minus M effect of this group, the percentage enol content is also lesser. And that product will be CH3COH, double bond CH, single bond C double bond O, O ethyl group. Right? This percentage of this group will be 7% here, minus M effect of this. So what happens here? See, you can also think like this. You may get confused. I'll just explain that part also. You can think, sir, we have this is the minus M effect we have. So it will, withdraw the electron pair toward this side. So the removal of H plus will be easier from this carbon. Is it? Did you understand this? Tell me. Right? What is the doubt you may have that this is the minus M group, so this can withdraw the electron towards its side. So the removal of H plus will be easy over here, right? So if it is easy, then this should be more acidic and percentage enol content should be more. Correct? But the point here is what? Because of this minus M group that you have, it will it will reduce the electron withdrawing tendency of this carbonyl group, because this carbonyl group is directly attached to this. Okay, you see, this is also pulling electron towards its side. This is pulling electron towards its side. This also has has electron withdrawing tendency. So both of these groups are competing with each other, right? So if this group is able to withdraw electron, if it is, then this will withdraw electron from here, from this group. The effect of this group will be more over here, right? So what we can say, the minus M group that is present over here, that will reduce the electron withdrawing tendency of C double bond O. Oh, I just, it's not minus M, it's plus M, no? Plus M or minus I, we can say, because of the lone pair on this oxygen. Correct? Yes, tell me quickly. Is it clear? Because it's lone pair, it has plus M and minus I, not minus M. Correct? So which one is dominant over here? Plus M, right? Plus M is dominating. So when plus M is dominating, so it has electron withdrawing tendency. So when it has electron withdrawing tendency, so electron withdrawing group of this, like the electron withdrawing nature of this group will get reduced now. Means electron withdrawing nature of this group from this carbon atom, that will be less because it is gaining electron from this side already. Correct. So because of this electron releasing group, the electron withdrawing nature of this group from this carbon atom, that is methylene group, will be less, and hence the tendency to lose H plus will also be less, and hence the percentage enol content will be less. Is it clear? Tell me, is it clear? Yeah. So the point here is, it is what, whatever factor we have discussed till now, that hydrogen bonding, steric hindrance, and all. This is the another factor we have, that is electronic effects. Depending on plus M and minus M, you can understand whether the tendency to lose hydrogen H plus ion is more or less, and then you can say, okay, this is again the another case we have. Now the next example you see, which is this one. This molecule. Its enol formula is what? Double bond here, this bond will be as it is, and we have OH here. Means this hydrogen will jump over here. You'll get this. Now you tell me which one is more stable here in these two. Enol form is more stable. Why so? See, this molecule has 4 pi electrons and hence it is anti-aromatic. So it is unstable. The percentage content is 0%. So this is the another factor we have, aromaticity. Is it clear? Now the another factor we got here is aromaticity. By enol form, in enol form, if the compound is gaining aromaticity, it means it is the most stable case, which we have discussed already in case of phenol, the first case. Correct? So this is the another factor. Aromaticity also you have to check if possible. Like this example you see, the eighth one. I have very strong feeling that you will get one question from this in the coming exam in March because they haven't asked any question on this. So you may probably get one question onto this. So must remember all these examples, okay? In this, the enol content, enol formula will be this. This compound is aromatic compound and hence it is 100%. Correct? One more example you see. Its enol content will be this. This is also anti-aromatic, 0%. Understood this? Few questions you got this year, this time, no, with aromaticity. I think these kind of questions was there. Which of these molecules are aromatic? Like this, few questions were there, I guess. Minus or plus. This kind of questions were there in the exam. I saw few papers. I think this was the one of the questions. Which one, Shweta? The first one. This is actually two, all these are conjugation, right? All these are conjugated system. 2, 4, 6, 8 pi electron we have directly. So 4n pi rule it is following. Correct. But the total, since all these are in conjugation, so total number of pi electron is what? 2, 4, 6, 8. We'll count all these bonds because it is not more than 2 ring that we have here. We have discussed aromaticity in the class, no? There we have discussed if we have more than 2 ring present, then we'll not count the, we'll count only peripheral pi bond. This one, they've asked this question, no? In the exam. Another example you see. In this, the possible product will be this. Or depending on the stability of these two products. So which one is major, which one is minor? First one and the second one. Okay. Why the second one is minor? Major, sorry. Second one is more, so all of you are saying second. Why second one is more stable? See, actually, in this molecule, this is the major product and this is the minor product. More substituted. Which one, Amog? Which one? Second one you are saying major. No, second one is minor. I'll tell you why. See, no matter what answer you are giving now, whether you are able to give the right answer or not, but from today onwards, after when we finish this class, you must keep all these factors and examples in mind. Okay, don't miss it. You see here, when you have double bond here, right? This carbon becomes sp2 hybridized, right? Means the bond angle should be what? Bond angle should be 120 degree, right? And because of this cyclopropane that you have here, the bond angle here is 60. Actual bond angle is 60. Because of hybridization, it should be 120. So bond angle should be 120 because of hybridization, but it is 60 over there. So you obviously have little bit of angle strain over there. Angle strain, you understood? This bond has tendency to form 120 degree of angle, but it is bonded to 60 degree only. So there will be a strain in this bond so that it will convert into 120, right? So that is the angle strain we have. And when angle strain increases, stability decreases. More angle strain, less will be the stability, right? But here you see what happens. Here also you can say, sir, there is angle strain, correct? But this carbon atom is sp3 hybridized. So for sp3 hybridization, bond angle is 109 degree 28 minutes. So obviously angle strain here it will be lesser than the angle strain here, correct? So because of this less angle strain here, this one is comparatively more stable than the second one. Is it clear? Clear? All of you understood this? So what all factors we have discussed so far? We have discussed hindrance. We have discussed H bonding. We have discussed aromaticity. Then we have discussed angle strain. We have also discussed effect, electronic effects, M effect and all, electronic effects. So all these factors affects the stability of enol form. Correct? So you must keep these all these factor in mind, and we have discussed around 10 to 12 examples. If you remember these 10 or 12 examples, you can solve any question based on this. They will not ask you anything more than this, whatever I have seen so far. Okay, you must remember these 10 12 examples and all these factor. That will be good enough. Okay, on the same thing, angle strain, I'll give you one more question, one more example. We'll see this one. Product also I'll write down the two possible product. One product is what, when we have double bond here and here we'll get OH, means what, when this hydrogen will take part into tautomerism, this double bond O will be as it is oxygen and this bond will be as. Another possibility is what, when this hydrogen takes part in tautomerism, then we get what, we'll get double bond here, OH, double bond O. Tell me the stable one or 1 and 2. Which one is more stable? First one is more stable. Reason? Do we have hydrogen bonding possible in 1 and 2? Angle strain. Hydrogen bonding is possible? Yes. Yes, hydrogen bonding is possible here. You see, here also we have hydrogen bonding, but hydrogen bonding is here also. In both the molecule, hydrogen bonding is possible. Okay. But first one is the major product we have. The reason being what? Because of less angle strain. Right? So the reason for the first compound to be more stable is less angle strain, not hydrogen bonding. Because hydrogen bonding is present in both the compounds. Correct? Right? So all these factors you must remember. Okay? You can have any molecules, but when you remember these factors, you can understand. And with percentage enol content also you remember. Whatever examples I have given you, percentage enol content you must remember, because factual question you never know what they are going to ask next. Okay? So percentage enol content you must remember. I have seen few question papers of career point. They have asked this question directly in matching, JEE advanced type. In match the column, they have asked this question. They have given four compounds here and the percentage in all content. You have to match those, right? So I have seen those questions in a question paper of test paper of career point. Okay, so you must remember that percentage in all content and then whatever the factors which affects the stability of in all content. Correct. So this is it for tautomerism. Okay, if you remember these all these examples, one more thing which I will not discuss now, but just I'll tell you, we have discussed in biomolecules fructose, right? Reaction of fructose we have discussed, and it contains the major functional group here. It is ketone, but then also, it gives tolerance test, right? Then also it gives tolerance test. The reason I have discussed already because of tautomerism only, the fructose form aldehydes, and that aldehydes gives tolerance test. Converts into glucose and mannose, if you remember, right? Remember this? Fructose, due to tautomerism only, converts into glucose and mannose, right? And hence it forms tolerance and it shows tolerance test. Correct? So they may ask you in tautomerism, they may ask you this question also, fructose related question also. So if they ask this, they'll cover both the chapters, biomolecules and tautomerism, both they'll cover over here. Okay, so this fructose part, tolerance test, you must remember it is important. Okay, understood this? Correct. So we'll take a break now. Okay, after this we'll start in 11. After 15 minutes we'll start. Okay, 11:15, 11:20 we'll start. Okay, we'll solve some questions. We'll solve some questions now. Okay, tautomerism we have finished. We'll solve some questions on some chapters. I'll give you some questions to solve. Correct. Can we take a break now? Okay, so we'll start at 11:20. Have you breakfast or whatever you want. Okay, we'll start at 11:20. Okay, hello, can we start now? Okay. JEE previous year paper you have solved, no? At least 5 year you have solved already. Yes. JEE previous year paper you have solved, right? Correct. So in this 1 month, you try to solve past at least past 5 years NEET questions. Do you have that question paper like previous year paper for NEET exam chemistry? Do you have that? Okay, so if you have that, then you start solving that. Okay, if you don't have, let me know. I'll just send you the question papers. Tell me the answer. I think this one we have solved already. Let it be. This question we have solved. B is correct. Okay. I'll give you the another question. I think this set of questions we have done. Okay, you see this question. Equilibrium we have done, I think. B is correct, fine. You see this question. The density in gram per ml of 3.6 molar H2SO4 solution having 29% H2SO4 by mass. One point six four, 1.88, 1.22, 1.45. Tell me this. I have given you one direct formula of this in solution chapter itself. Is it C? 1.22. Samir got C. Amog, what is the answer? Amog, Vishisht, Vaishnavi, Shruti, Kushal, what is the answer? Ramchandra, what is the answer? Tell me, Sanjana. Aditya, what is the answer? C is correct, 1.22. Check your calculation, Aditya. See, we have this question. Suppose we have 100 gram of solution, right? In this 100 gram, we have 29 gram of H2SO4 and rest is what? 71 gram is solvent, right? So molarity is given. So with molarity, you can find out the volume of solution, right? Density will be what? Mass by volume. So mass is 71 divided by volume that you have here. This is what you have done. 1.22 is the answer. It is 29 by 98 into 100,000. So volume is equals to molarity is 3.6 into 98 divided by 29 into 1000. So density will be 71 into 3.6 into 98, 29 into 1000. . Is it 21 or 20? It's 29%, not 21. Shweta, is it? Is it reciprocal of that? Yeah, correct, correct. Yeah, correct, correct. So 1 by this. That's what I was also thinking. Yeah. So density will be mass by volume. So 71 divided by 29 into 1000 into 3.698. Is this 71 is correct? We cannot take 71 here because you see density of solution we have to find out, no? 71 is the mass of solvent, so we should take here 100, right? So you see this becomes what? 100 into 3.6 into 98 divided by 29 into 1000. So you see what is the here what is the formula we can write? This 29 is what? It is a percentage weight of solute, right? So this becomes density is equals to 3.6 into 98 divided by 29 into 10. Okay. And molarity we can write from, this is molarity, right? So molarity we can write what? Molarity is equals to density into percentage weight of solute into 10. This whole divided by 98 is the molecular mass of solute. This is the formula we have. Density, percentage weight of solute, 10 divided by molecular mass. So when you solve this, you will get 1.22 gram per ml. Correct? Right? Now, next question you see, did you understand this? Can we move on? You have to plot this. Plot of, I have done this in the class. Tell me the answer. Plot of 1 by XA and 1 by XA and vapor phase we have. No. 1 by YA is linear whose slope and intercept are. You have to find out the slope and intercept. I'll give you the option. P naught B by P naught A. P naught B minus P naught A divided by P naught B. Option B. P naught A minus P naught B. This is the vapor pressure of actual of the pure one. All this P naught term that we have. P naught A minus P naught B. P naught B. P naught A by P naught B P naught B minus P naught A divided by P naught B. P naught B by P naught A. P naught A minus P naught B divided by P naught B. Tell me the answer. If you do not remember, you can derive this also in one single step. What is the answer? Okay, I'll give you one hint. The partial pressure of A is equals to, we can write the mole fraction in liquid phase into total pressure, and that will be equals to mole fraction into vapor phase into the vapor pressure, P naught A. You're getting A. Okay, see this. So this we can write the mole fraction of A in liquid phase is equals to the mole fraction of A in vapor phase, vapor pressure divided by total pressure. Similarly, mole fraction of B is what? XB is equals to YB P naught B by PT. Right? This is 1 and this is 2. If you divide 1 by 2, because what happens here, this total pressure we have to eliminate. Right? Or you can also put P naught A XA plus P naught B XB. That also you can put. Okay? So XA by XB is equals to what? YA P naught A by YB P naught B. We don't need B, right? XB, YB we don't need. So XB we can write 1 minus XA, and YB we can write 1 minus YA into P naught A by P naught B. Now you can solve this and you can form the equation of 1 by XA and 1 by YA. Okay, you'll get option C as the right one. Yes, correct, Simon. Option C is correct. Understood, all of you? Next question, right? Okay, you see this? How many ml of 0.1 molar HCl are required to react completely with completely with 1 gram mixture of Na2CO3 and NaHCO3 containing equimolar amount of these two. Options are 157.8 ml, 0.1578 ml, 210.4 ml, 105.2 ml. Solve this. Got it? Okay, what you do, I'll just give you some hint. 1 gram mixture of Na2CO3 and NaHCO3 you have. Okay. Assume one of these as X, so other one will be 1 minus X. Since they have equal number of moles, so equate their number of moles, you'll get X from there. Two different reaction, both Na2CO3 and NaHCO3 will react HCl, will react with HCl separately, like this. You see what happens here. Na2CO3 combines with HCl, gives what we'll get over here, NaCl plus H2O plus CO2, right? If you balance this, we'll get 2 moles of HCl, 2 moles of NaCl. Similarly, NaHCO3 also combines with HCl, forms NaCl plus H2O plus CO2. So both in the both reaction, the volume of HCl we are using here. Since the volume of HCl we have to find out, right? And 2 volume of this we are using. So when you compare this and this, the volume of Na2CO3 will be used here. That will be twice to that of NaHCO3, because the ratio is 1:2 here, 1:1 here. For 1 mole we use 1. For 2 mole we use 1. So like that. So what do you have to apply here? The M1V1 for HCl is equals to M2V2 for Na2CO3 plus M3V3 for NaHCO3. Right? This volume you have to find out. Okay. So nothing, see, the volume of this is not given, NaHCO3 and Na2CO3. So we'll assume the volume as 1 and 1 over here. But the point here is what? Since the reaction reacts completely, what is given? Completely reacts, right? So 2 volume of this reacts with 2 volume of this. Okay, that's what the point we have. Okay, so to complete this reaction, we required 2 volume of Na2CO3 and 1 volume of NaHCO3. Correct? So here the molarity of HCl is given, which is 0.1 into V1 we have to find out. We'll write volume of Na2CO3 is 2, molarity we do not know, plus 1 into molarity of this we do not know. V1 we have to find it out. Now what we can say, since we have 1 gram mixture of this Na2CO3 and NaHCO3 we have, so out of this, suppose X gram of Na2CO3 we have, then 1 minus X gram of NaHCO3 will be there. So equal number of moles we have, so number of moles will equate. So X divided by the molecular mass of this will be 106 is equals to 1 minus X, molecular mass of this will be 84. You solve this for X, X will be 0.5578. Approximately this is the mass you'll get. So number of moles of Na2CO3 will find out, because molarity we have to find out, and that will be equals to the number of moles of NaHCO3, which is equals to 0.5578 divided by 106, and this you will get 0.00526 moles, right? Molarity will assume, volume will assume as 1 over here. So concentration molarity will be this only. Number of moles is nothing but the concentration. That will substitute over here. So 2 into 0.00526 plus 0.00526. You solve this equation, you'll get V1 as 157.8 ml. So this is the answer we have here. Yes, right. Right? Option A is correct. Next question you see. The aqueous solution, next one. An aqueous solution of 2% weight by weight. Weight by weight, non-volatile solute. Solute exerts a pressure of 1.004 bar at the boiling point of solvent. Find out the molecular mass of solute. Molecular mass of solute is equals to what? Options: 0.3655, 36.55, 41.34, 40.16. What is the answer? 41.5. Yeah, it's close. So it's C is correct. What happened, others? I think you did not revise this chapter properly. These are direct formula based. See, actually, should I explain it? We don't have time. Tell me the last question for today. Amog, what happened? Amog, Aditya, Vaishnavi, Kondani, are you there? Okay. You see this, first of all, I have already told you that in this type of questions, just write down the data first. Okay. So you see, exerts a pressure. So the solution pressure is given, right? That is P is equals to 1.004 bar. The solution pressure is given, right? Now the mass of solute. So the weight of solute is what? I assume 2 gram. So weight of solvent will be 98 gram, right? And since it is aqueous solution, it is. So the molecular weight of solvent is 18, which is nothing but water. Molecular weight of solute we have to find out. What formula we can apply? P naught minus P divided by P naught is equals to number of moles of solute NB by Na, right? Number of moles of solvent. This formula we can apply, right? This is the formula. We have P naught minus P naught A minus PB is minus P divided by P naught is equals to number of moles of solute by solvent, which is NB by Na. Correct? So this pressure is given already 1.004. Number of moles of solute you have weight by molecular weight. So molecular, if you know this number of moles, you can find out molecular weight also. That is what we have to find out. And number of moles of solvent is already there, 98 by 18. Correct? Only thing is not given here, which is P naught. It is not given directly, but indirectly it is given, because it is saying that exerts a pressure of 1.004 bar at the boiling point of solvent. So what is the boiling point of solvent? Solvent is H2O. Boiling point is 100 degrees Celsius, and we know water at 100 degrees Celsius will be at equilibrium, right? Equilibrium, which is vapor form, right? So this is the equilibrium condition, and that is only possible when the vapor pressure of solution is equal to the atmospheric pressure. Correct? Vapor pressure of solution is equals to atmospheric pressure. So the vapor pressure of solution will be what? Is equals to the atmospheric pressure, which is nothing but 1 atm. And in bar, if I write down, it will be 1.013 bar. The P naught is this. I have done this kind of question, that when equilibrium is given or boiling point of water, when solvent boiling point is given, then the pressure P naught we always take is equal to the atmospheric pressure, which can be 760 mm or 1 bar, 1.013 bar. Till here, is it clear? Tell me. Now you have to substitute this value here. P naught is 1.013 minus P is 1.004 divided by 1.013 is equals to number of moles of solute divided by number of moles of solvent. You substitute this value, you'll get number of moles of solute from here, which is nothing but the weight of solute is 2 gram. Molecular weight you have to find out. Okay, and then you will get the answer. So in this kind of question, solution question, you just write down the data and you try to apply the formula. Okay, you will understand that what you have to do, what is given, and what is you have to find out. Okay, but first I always told you this, that first you write down the data like this, you will understand what formula you have to apply. And one more thing you must keep in mind, that when the pressure of vapor pressure of pure solution is not given, okay, then you have to take pressure is equals to the atmospheric pressure. There is no other way to do this. Okay, if it is not given, then you must think on this, that the pressure must be equals to atmospheric pressure. Then according to the pressure given, unit of the pressure, you can take the value 760 mm or in bar. Okay, this vapor pressure of pure solution, it is the experimental thing. You cannot tell that vapor pressure of solution will be this. Okay, it should be given in the question. If it is not given, then by any means they'll make you understand this, that the solution pressure is equals to the atmospheric pressure. Okay, and that is how they have mentioned over here. That is what they have mentioned over here. Boiling point they have mentioned. Boiling point is only defined when the pressure exerts by the liquid is equals to the atmospheric pressure. Okay, so the vapor pressure of the liquid is equals to the atmospheric pressure, then only the liquid starts boiling. It means the pressure of solution here is equal to the atmospheric pressure, and that is nothing but 1.013 bar. Is it clear? Did you understand this? Right. So okay, so we'll wind up the class here only. Okay. Next class we'll discuss few things in hydrocarbon. Hydrocarbon we haven't discussed, right? Did we discuss hydrocarbon? Okay, so next class we'll discuss few reactions of hydrocarbon and see some questions onto that. Okay, because hydrocarbon reactions are very important for all other organic chapters. Okay, and I'll suggest you again to solve JEE last 5 year question. If you have solved, just go through the NEET or any AIMS paper, last 5 years papers of NEET and AIMS exam. Okay, chemistry at least you must see that. Okay, because there you'll get some factual question. And again, one thing, whatever the factual question you get, you just note it down in your notes. Okay, don't forget to do that. Okay, so that you can revise those factual questions in last 1 or 2 days when the exam was there. Correct. So we'll stop the class here only. Thank you for joining. See you soon. Bye and happy Pongal, all of you. Enjoy.